Fluid-filled catheters have been used for many years for the measurement of pressure. Now in this setting, the sensor is located some distance away from the end of the catheter where the pressure is actually being recorded from. Now this leads to a lower frequency response of the sensor, of the catheter, but also importantly in a conscious animal setting provides susceptibility to movement artifact as the animal begins to walk. However, the new solid-state sensor and telemetry system developed by Telemetry Research and Millar instruments gets around that problem because the sensor is located right at the very tip of the catheter. The transmitter is located within the abdomen of the animal and transmits out the corresponding waveform. Now we're going to illustrate this property of high frequency response and imperceptibility to movement of the animal by recording the blood pressure waveform from two animals live. You'll see the waveforms on the left hand side and two rats moving on the right hand side. One rat has been labeled with a red pen to indicate the red. It corresponds to the red signal on the top panel. In the second part of the video, you're going to see one of the animals moving, freely moving, if you like, playing on a researcher's lab coat. And it again illustrates the lack of effect of movement on the blood pressure waveform and just how dynamic that waveform is in changes in conscious animals. In this video, we've introduced a number of key features associated with the new Millar-enabled TR pressure transmitters. The first point is that movement of the animal, which causes movement of the catheter, does not affect the signal quality. The second point, that orientation of the animal, such as moving from standing to supine or during even exercise, doesn't cause movement artifacts. The third point is that the high fidelity of the solid-state sensor with a very high frequency response and sampling at 2000 Hz provides a very good fidelity of the waveform. The final point is, which we haven't really dealt with in this video, but is certainly evident by having two animals with the same type of transmitters present, is that we can have multiple channels available for transmission of the signal without inducing crosstalk. So cohabitation of the animals is simply not a problem. A range of other videos surrounding surgical approaches for implantation of transmitters, the use of the transmitters, care of the transmitters, cleaning, etc. can be found on our website, telemetryresearch.com, but also don't hesitate to contact us for further advice and information, tips on experimental design, etc. We're always ready to help.